So let us start today's topic. In the last lectures, we seen the concept of Bernoulli polynomial, that is BKT, and BKT is what? It is the sequence of functions or polynomials whose exponential generating function is x into e to the power tx upon e to the power x minus 1. X into e to the power tx upon e to the power x minus 1, isn't it? So that means what? BKT is obtained by using this relation, summation, x into e to the power tx upon e to the power x minus 1 equal to summation k from 0 to infinity BKT upon k factorial into x to the power k. So the solution, the values of BKT obtained by equating these two terms is called Bernoulli polynomial. It is called Bernoulli polynomial. Okay. Now it is called Bernoulli polynomial. Then we have seen Bernoulli numbers. In the Bernoulli polynomials, put t equal to 0. The numbers we obtained is called Bernoulli numbers there. Okay. Bernoulli polynomials, Bernoulli numbers. Then we have seen obtained some initial Bernoulli polynomials and Bernoulli numbers. That is b0 of t equal to 1, b1 of t equal to t minus 1 by 2, b2 of t equal to t square minus t plus 1 upon 6, b3 of t equal to t cube minus 3 by 2 t square plus 1 upon 2. Right? And by putting t equal to 0 in each of these, that is in b0 of t, b1 of t, b2 of t and b3 of t, we obtain b0t, b0 of 0, that is b0 equal to 1, b1 equal to minus 1 by 2, b2 equal to 1 upon 6, b3 equal to 1 b3 equal to 0, because each of term contains t there. So these are the initial, that is first three Bernoulli numbers. This is initial Bernoulli number, first Bernoulli number, second Bernoulli number and third Bernoulli. Okay. These are the first three Bernoulli. Then what we have seen? We have seen the properties, in which in detail we have seen this property. Bk dash of t equal to k into bk minus 1 of t for k greater than or equal to 1. We have discussed this total property. Now we will discuss this b again. Delta of bk of t. This is the derivative of Bernoulli polynomial and this is the difference of Bernoulli polynomial. So what is the derivative of Bernoulli polynomial? K into bk minus 1 of t. And what is the difference of Bernoulli polynomial? K into t to the power k minus 1. That we want to go. K into, this is the b. Now we know that these two are same, that is x into e to the power tx upon e to the power x minus 1 equal to summation from k equal to 0 to infinity bk of t upon k factorial into x to the power k. Taking delta of both sides with respect to t. क्या कर रहे हैं हम यहाँ? We are taking difference on both sides with respect to t. That is, now if I take difference, what we can write? K from 0 to infinity, difference of bkt, right? Because we want to take with respect to t, so this is the function of t. Difference of bkt with respect to t upon k factorial constant term with respect to t. Therefore, as it is into x to the power k. This is also constant as far as t is concerned. As far as t is concerned. That's why it is as it is. So only we have to take delta of bkt, not any other. And summation is there, so you can take separate. Therefore delta outside जो है वो क्या हो जाएगा? It will goes inside, because delta of addition of two terms is equal to what? Separate delta you can take there. That we have used. Equal to. यहाँ भी देखो आप. Take the terms which are independent of t outside this delta. So x upon e to the power x minus 1 we can take outside, and only we have to take delta of e to the power tx. What is the delta of e to the power tx now? e to the power t plus 1x minus e to the power tx. डेल्टा कैसे निकालते हैं? t is replaced by t plus 1 and then t as it is. Now again if we see here, e to the power tx into e to the power x minus e to the power tx. Take e to the power tx common, we get x upon e to the power x minus 1 e to the power tx into e to the power x minus 1. Now what it will be? E to the power x minus 1 cancels with e to the power x1 x minus 1 and you will get only x into e to the power tx. You will get only x into e to the power tx there. Okay, now therefore see here, what about right hand side? Therefore summation from which is equal to summation from k equal to 0 to infinity x into xt to the power k upon k factor. Why this obtained? As this your series, this is x into e to the power x. So can I write this is equal to x into e to the power x के लिए ये फार्मूला है, summation from k equal to 0 to infinity this tx to the power k upon k factorial. क्यों? Because e to the power x के लिए फार्मूला है अपने पास e to the power x equal to summation from k equal to 0 to infinity x to the power k upon k factorial. That is, this is 1 plus x square upon 2 factorial plus x cube upon 3 factorial and so on. Yeah, expansion. By using this expansion, you will get this term. Okay, now which is equal to summation from k equal to 0 to infinity x into, अभी ये x जो बाहर है because of it is from k, kx बाहर है वो अंदर भी जा सकता है, so x into xt to the power k upon k factorial equal to summation from k equal to 0 to infinity. Now this can be written as t to the power k into x to the power k plus 1 upon k factorial right? Therefore okay. So what you will get here, this can be written as summation from k equal to 1 to, अब ये पहला टर्म क्या हो जाएगा आपका, if I put k equal to 0, what will be your first term? T to the power k means t to the power 0 into x to the power 1 upon 0 factorial. 0 factorial is 1. इसका मतलब है फर्स्ट टर्म आपका x आ जाएगा. So what I will do here, in place of writing k from 0 to infinity, I will write k from 1 to infinity. अगर 1 से चालू कर दिए तो you will get t to the power k minus 1 because t to the power 0 आना चाहिए, यहाँ k minus 1 रखा और k is equal to 1 पुट किया तो t to the power 0 आता है, x to the power 1 आता है upon 0 factorial आता है. So this left hand term is same as this one. Now in left hand summation is from x to the power k and in right hand it is x to the coefficient is what, x to the power k और यहाँ भी coefficient क्या है, x to the power k. So दोनों में से first coefficient देखो equate कर दो, second equate कर दो, third equate कर दो. So what will happen? So this term delta t of pkt upon k factorial will be same as t to the power k minus 1 upon k factorial, t to the power k minus 1 upon k factorial, equating same powers of x, So delta t of bkt upon k factorial equal to t to the power k minus 1 upon k minus 1 factorial. Now this k factorial goes here in multiplication, k factorial and denominator is k minus 1 factorial. This k factorial can be written as k into k minus 1 factorial, that cancels with this k minus 1 factorial and therefore delta t of bkt equal to k into t to the power k minus 1 for all k greater than or equal to 0. So in this way we can obtain difference of bkt. Here first we obtain derivative of bkt. बर्नौली पॉलिनोमियल का डेरिवेटिव क्या आता है और बर्नौली पॉलिनोमियल का डिफरेंस क्या आता है. इंटीग्रल भी एक एग्जांपल में है, दैट वी विल सी लेटर. नाउ थर्ड बर्नौली पॉलिनोमियल bk is equal to bk of 0 equal to bk of 1. That means bk of 1 is same as bk of 0 is same as bk, that we want to prove for k not equal to 1, k 0 नहीं होना चाहिए. That means what, b2 होना चाहिए या फिर b0 होना चाहिए, right? So b0 is equal to b0 of 0 is equal to b0 of 1 आना चाहिए, isn't it? It is like that. Then b2 of 0 equal to b2 of 1 आना चाहिए. Then b3 of 0 equal to b3 of 1 and so on. ये टाइप से आने से. So how you will prove it? We know that difference of bkt equal to k into t to the power k minus 1, right? For any value of k is now there, right? Therefore, delta t of bk of 0, I will put t equal to 0. You will get right hand side as 0. So delta k of bk of 0 is equal to 0. That means bk of 1 minus bk of 0 equal to 0 for k not equal to 1. This is for k not equal to 1. Maybe k equal to 1 right? K not equal to 1. Therefore, bk is equal to bk of 0 equal to bk of 1. So as it is 0, these two will be same. That is very simple. Now, अगर आप ध्यान से देखिए तो थर्ड बर्नौली पॉलिनोमियल आपकी क्या है, b3 ऑफ t इज इक्वल टू दिस वन t क्यूब माइनस 3/2 t स्क्वायर प्लस 1/2 t. यहाँ कांस्टेंट टर्म इज एब्सेंट है. कांस्टेंट टर्म क्या आती है? एब्सेंट आती है. b0 में कांस्टेंट टर्म आती है, b1 में आती है, b2 में आती है, लेकिन b3 में नहीं आती, राइट? सो अगर आप इससे अभी b4 निकालेंगे, दैट विल गेट फोर्थ डिग्री पॉलिनोमियल इन विच अगेन कांस्टेंट टर्म इज एब्सेंट. If we obtain b5 of t, you will get fifth degree polynomial in t in which again constant term is absent. That means b3 और उसके आगे सभी में ऐसे polynomial आते हैं जहाँ constant term is absent आते हैं. So if I put now t equal to 0 here, every time this is going to be 0. अभी b3 of 0 equal to 0 आने वाला है, b4 of 0 equal to again 0 आने वाला है, because as there will not be any constant term there, any constant term. You can see this. You find b4 of t, you find b5 of t, you find b6 of t, and you do like that. You can say that there is no constant term in this polynomial, and therefore b2m plus 1 of 0 is always going to be 0, where m is equal to 1, 2, 3, etc. 2m plus 1 का मतलब क्या है? यहाँ देखो 2m plus 1, b2m plus 1 at 0, isn't it? That is Bernoulli number where m is greater than or equal to 1. If I put m equal to 1, ये b3 आता है. If I put m equal to 2, right, b5 आएगा. If I put m equal to 3, b7 आएगा. So ये जो सब odd multiples वाले हैं आप देखेंगे, odd suffix term b3, b5, b7, b9, in every term there will not be any constant term, and hence the value at t equal to 0 becomes 0. That we want to only say here. Delta again we have taken same thing, and this is there as like in this category. Delta t of b2m plus 1 of t is equal to b2m plus 1 of t to the power 2m. If I put t equal to 0, you will get this, that is b2m plus 1 1, but this is going to be 0. Therefore, b2m plus 1 of 1 equal to 0 again. That we are taking here. Okay. So, now we will see one corollary there. If k equal to 0, 1, 2, etc., then summation t to the power k equal to 1 upon k plus 1, bk plus 1 of t plus c of t, where delta ct equal to 0. What we are finding here? Summation of t to the power k. t to the power k का summation निकाल रहे हैं आप, देखो आप. इससे पहले we have obtained summation of t to the falling r. क्या आता था? t to the falling r plus 1 upon r plus 1. falling power का summation हमें पता था by using those, right? अभी यहाँ power का भी summation आ रहा है. You are taking the power. Delta of t to the falling r भी निकाला है हमने. क्या निकाला है? r into t to the power r, t to the falling power r minus 1. This formula also we have. तो हमने क्या बोला था कि there is no definite formula for finding delta of t to the power n. उसके लिए आपको ये t to the power n को falling power में convert करना होगा. Then and then you can find delta. Summation का भी निकालते समय we have used this formula, summation of t to the falling r equal to t to the falling r plus 1 upon r plus 1. But you have not obtained the formula for obtaining summation of t to the power r. और उसके लिए ये formula है. Summation of t to the power k equal to 1 upon k plus 1, bk plus 1 of t plus c of t, where delta ct equal to 0. That is, we can obtain summation of power of t using Bernoulli polynomial, by using Bernoulli polynomial, not by using any other method. Now, How we obtain this? We know that the difference of bkt with respect to t equal to k into t to the power k minus 1. We have this here. है आपके पास डेल्टा t of bkt equal to tk into t to the power k minus 1. So delta t of bkt equal to t into t to the power k minus 1, which implies delta t of bk plus 1 of t equal to k plus 1 t to the power k. क्या किया है हमने सिर्फ यहाँ रिप्लेस t by t plus 1. यहाँ क्या कर दो आप k, sorry, replace k by k plus 1. Everything remains as. So if I take k by k plus 1, here k by k plus 1, and here k by k plus 1. So delta t of bk plus 1 of t equal to k plus 1 t to the power k. Now using definition of summation, अगर इसका डेल्टा bk plus 1 का डेल्टा ये आता है तो by using definition of summation इसका summation bk plus 1 आना चाहिए, and therefore summation of k plus 1 t to the power k must be this bk plus 1 of bk plus 1 of t, isn't it? So as delta of bk plus 1 of t is equal to k plus 1 into t to the power k, therefore summation of k plus 1 into t to the power t must be equal to bk plus 1 of t. That is, यहाँ आप लिखो this is a summation with respect to t, so k plus 1 is constant that can be taken outside. So we get k plus 1 into summation of t to the power k equal to bk plus 1t. Let that k plus 1 to here, that is in the denominator. So summation of t to the power k equal to 1 upon k plus 1 bk plus 1t plus c of t, where delta ct equal to 0. So this corollary gives formula for obtaining summation of t to the power k. Already we have summation of t to the falling power k. Now we get summation of t to the power k in terms of Bernoulli polynomial. So if we know the Bernoulli polynomial, then we can obtain summation of t to the power k. It is just something what we can say the difficult job. That's why we can convert this power k into falling power, and then we can obtain it. Okay. As before we have seen that we have obtained delta of bkt, derivative of bkt, but we haven't obtained integral of bkt. And for that we have one example there, that is for obtaining integral of bkt. So we can show that integral from 0 to 1, definite integral from 0 to 1 of bkt with respect to t equal to 0 for k is greater than or equal to 1, for k is greater than or equal to 1 there. Okay, this can be proved. We can prove this term there. Okay, how to prove it? Now to prove this we will use the formula for obtaining derivative. Derivative का जो formula है that we will see. क्या formula है अपने पास derivative of bkt? We know that we have bk dash t, bk dash of t equal to क्या formula है आपका? Equal to k into bk minus 1 of t, k into bk minus 1 of t for t greater than or equal to 1. Correct है? We have this formula. Now therefore अगर bk का डेरिवेटिव ही आता है, therefore bkt क्या हो जाएगा? bkt becomes integral of k into bk minus 1 of t into dt, again for t greater than or equal to 1. There is we have used here the concept of derivative and integration. अगर bkt का डेरिवेटिव ये आता है तो इसका इंटीग्रल bkt आना चाहिए, and therefore integral from 0 to 1 k into bk minus 1 of t into dt क्या आ जाएगा? This will be bkt from what? 0 to 1. That is bk at 1. Correct है? That is what? Can I say like this? bk at 1 minus bk at 0 equal to k times integral from 0 to 1 bk minus 1 of t into dt. Bk minus 1 of t into dt, right? That we can see. Now, therefore, integral from 0 to 1 bk minus 1 of t into dt equal to what you will get 1 by k into bk of 1 minus bk of 0. Therefore, integral from 0 to 1 bk of t dt becomes क्या होना है k is replaced by k plus 1, so it is equal to 1 upon k plus 1 b k plus 1 of 1 minus b k plus 1 of 0. बराबर है. But for k greater than or equal to 1, k greater than or equal to, but already we have proved something. k greater than or equal to 1 के लिए कुछ प्रूव किया है क्या आपने? bk plus 1 of 1 equal to bk plus 1 of 0. Where it is? It is there. See here. bk for any k, bk of 0 is same as bk of 1. bk of 0. If bk plus 1 of 0 will be again bk plus 1 of 1, and therefore these two terms will be same. That means this is equal to, this is going to be equal to 0 for k greater than or equal to 1. For k greater than or equal to 1. So in this way you can obtain the integral of bkt with respect to t. We can obtain integral of bkt with respect to t there. Okay. Then we have one more example regarding this. Generating functions and exponential generating function. This is again an interesting example. The function gtx is equal to e to the power 2x minus x square is the generating function for Hermite polynomial HNT. Then compute HNT for n lies between 0 to 3. n lies between 0 to 3. Isn't it? आपको क्या करना है? h0 of t, h1 of t, h2 of t and h3 of t निकालना है. What we have given for that? gtx is equal to e to the power 2tx minus x square is the generating function of hnt. ऐसा दिया है. What we have given? This e to the power 2tx minus x square is the generating function for hnt दिया है, और by using this you have to obtain hnt for n is equal to 0, 1, 2 and 3. That is, we want to obtain h0 of t, h1 of t, h2 of t and h3 of t and h3 of t. Now summation, we given this one, summation k from 0 to infinity hn of t into x to the power n. If it is n, it should be n. If it is k, it should be k. So I will take n here in place of what we are saying. This is not k, this is n equal to 0 to infinity of hnt x to the power n e to the power 2tx minus x square, because what we are given that this function is the generating function for hnt. We know that gtx is called generating function for some whatever ykt if gtx equal to summation from k equal to 0 to infinity ykt into x to the power k. That k I have taken it as n only. That is only thing, nothing else. Okay. So summation from n equal to 0 to infinity hnt into x to the power n equal to exp means what? It is just this term. So be careful. Before writing exp is nothing but e to the power 2tx minus x square. Both are same. These both terms are same. So exponential of 2tx minus x square means e to the power 2tx minus x square equal to 1 plus 2tx minus x square plus 1 upon 2 factorial 2tx minus x square its square plus 1 upon 3 factorial 2tx minus x square its cube and so on. What we use here? If in place of this e to the power 2tx minus x square, we have e to the power theta. How you can write e to the power theta? 1 plus theta square by 2 factorial plus theta cube by 3 factorial and so on. ये जो है आपका expansion of e to the power theta है, power series expansion. So in place of theta, what is there? In place of theta, there is 2tx minus x square. There is 2tx minus x. So that's why I have taken 1 plus 2tx minus x square plus 1 upon 2 factorial 2tx minus x square its square plus 1 upon 3 factorial 2tx minus x square its cube and so on by using this. It's very simple. Now 1 plus 2tx minus x square as it is plus 1 by 2 factorial means 1 by 2 only. Now what about a minus b square? You have used just a minus b square. A square minus 2ab plus b square. So a square means 2tx square, that is 4t square x square, minus 2 into 2tx into x square, that is minus 4 into t into x square as x cube, and plus b square x square ka power 4 plus 1 upon 3 factorial means what? 1 upon 6 into 8t cube x cube. Why? We want to take a minus b cube. What is the formula for a minus b cube? You know the formula for a minus b cube. What is it? A cube minus 3a square b plus 3ab square and minus b cube. Minus b cube. Using this formula, so first term cube, that is 2tx का cube है, 8 into t cube into x cube, minus 3 times पहले का square, second as it is. इसका अगर square निकाला तो 4t square x square into x square, that is 4t square x to the power 4 और उसको t 3 से multiply करना, that is 6 minus 6t square x to the power 4. Then यहाँ cube है तो next term plus आ जाएगी, that's why it is plus 3 times a into b square, 3 2tx x raised to 4, therefore 6t x to the power 5 minus b cube, x square ka cube, x raised to power 6 and so on. Higher powers of x will be there, no problem. Now we will collect the same powers of x. So there is only one constant term which is 1 and we will take 1 as it is. Plus collect the powers of x only. So there is again only one term is there which is power of x only, 1 plus 2tx. Plus, now see here, now we will collect the powers of x square, means coefficients of x square. We will collect the second power of x terms, or we can say that we collect the terms of x square. So x square की term आपने की है तो ये term क्या होगा 1 by 2 4t square x square, that is 2t square x square minus x square. So I will take x square common, we get 2t square minus 1 which is there. Now we will collect the terms of x cube. x cube के term हम पूरे collect करेंगे. ये देखिए यहाँ तो नहीं है. First term is 1 by 2 into minus 4t x cube, that is minus 2t x cube, minus 2t x cube. Then 1 by 6 8t cube x cube, that is 4 by 3 t cube x cube. ये अलग हो जाएगी दूसरी term. So first term यहाँ क्या होती है? First term is minus 2t x cube. ये हो गई पहली term. Then second term क्या होती है? Plus 4 by 3 t cube x cube. 4 upon 3 t cube into x cube. Then is there any other term of x cube? Okay, यहाँ तो नहीं है, आगे हो जाएगी, right? What about here? यहाँ तो term आपकी x to the power 4 वाली आएगी, because we have to take fourth power. Fourth power अगर है, then this term becomes x to the power 4 there. This term becomes x to the power 4 and so on. So we don't want to go for fourth power. We will stick up with up to third power, right? So what you will get 1 plus 2tx plus 2t square minus 1 x square plus. Now I will take x cube common from here and here. What you will get? 4 by 3t cube minus 2t. 4 by 3t cube minus 2t into x cube plus so on. ऐसे बहुत सारे टर्म वहाँ रहेगी. So this is in the power increasing power of x. ऐसे लिखे. What is the your left hand side? Left hand side क्या है यहाँ? Summation from n equal to 0 to infinity hn of t into x to the power n. ऐसे लिख सकते हैं हम left hand side को. Your left hand side is like this: h0 of t plus h1 of t into x plus h2 of t into x square plus h3 of t into x cube and so on. I see left hand side here, isn't it? This is the left hand side expansion. Summation from n equal to 0 to infinity hn of t x to the power n. So h0 of t x to the power 0, h1 of t x to the power 1, h2 of t x to the power 2, h3 of t x to the power 3 and so on. Therefore, now if I compare these two sides, compare constant terms. So 1 is equal to h0 of t. So h0 of t is equal to 1. Then the coefficient of x is 2t here and it is h1t here. So h1t equal to 2t. Then coefficient of x square. 2t square minus 1 is in the right hand side while h2t in the left hand side. So h2t is equal to 2t square minus 1. h3t equal to coefficient of x cube here 4 by 3 t cube minus 2t. That is equating coefficients of same powers of x, we get h0t equal to 1, h1t equal to 2t, h2t equal to 2t square minus 1, h3t equal to 4 by 3 t cube minus 2t and so on. In this way, you can also find h4t, h5t, h6t and so on. That means what? If you have given any function as the generating function for any polynomial, then we can find preliminary the polynomials or h0, h1, h2 and so on. शुरुआत के जो पॉलिनोमियल्स है या फिर सभी निकाल सकते हैं लेकिन उसके लिए टाइम ज्यादा लगता है. दैट इज मोर कैलकुलेशंस आर नीडेड. दैट्स व्हाई वी आर टेकिंग हियर अप टू 0, 1, 2 एंड 3. आप दूसरा फंक्शन ले लीजिए और सो एंड ऐसे भी एक एग्जांपल है आपको होमवर्क में. दिस इज अनदर फंक्शन, कोई और पॉलिनोमियल के लिए है और आपको बता दिया है कि फाइंड आउट h0, h1, h3 एंड सो ऑन. सेम मेथड इज देयर. इसको एक्सपांड कर दो इन टर्म्स ऑफ समथिंग constant term plus something into x plus something into x square plus something into x cube. Compare these two, you will get h0 or whatever the L1, L2, L3 or P1, P2, P3, P0. ऐसे क्या हो जाएंगे वो आ जाएंगे. Okay, this is also example that is depend on that generating function. That's why we have taken actually. Okay, so there are so many other examples. ये तो हमने already ले लिए हैं. We have taken these examples there. Okay. So in this way you can find the initial means initial functions whose generating functions are given, whose exponential generating functions are also given, and this is all about Bernoulli numbers as well as Bernoulli polynomials. For today we will stop here.